Hello everyone. In this lesson what we're going to do is we're going to look at how the periodic table came about and how the elements ended up being arranged on the table. Now, when chemists originally designed the periodic table, Dmitry Mendeleev was the person who's credited with coming up with the first pattern for the table that made any kind of sense. They they didn't know everything about the elements, and some of the elements they didn't know about at all. But for the purposes of this little demonstration, I'm going to assume that I know the first 20 elements. I know their properties, some mainly physical, but some chemical properties as well. And that I know how many protons there are in each of the atoms of each element. So, for example, in element number 1, hydrogen, it has 1 proton. And element number 6, carbon, has 6 protons. So I can arrange my table, it's the simplest way to arrange it. I can arrange it in terms of numbers of protons, because every element is different according to its number of protons. So let's see what we know. So we know some chemical and physical properties. And we know number of protons in each element. Now, what I want to do is I want to arrange elements. Arrange elements 1 to 20, okay, in a table. Now, how hard can that be? I'm somebody who was brought up in the decimal system, so I can easily have a table with 2 rows in it, each having 10 elements in it. That makes perfect sense to somebody who's brought up in a decimal world. So let's try that. I'm going to take my numbers of protons, and I'll call that my number of the element as well, shall I? Because I know that only atoms with 1 proton are hydrogen. So 4, 5, 6, 7, 8, 9, and 10. Well, that's easy, so let's bung them in. Hydrogen is the first one. Then we have helium. And we have lithium. And then we have beryllium. And we have boron and carbon and nitrogen and oxygen and fluorine and neon. All right, see if I can remember the next lot. So underneath this, I'm going to put elements 11 to 20. So we'll put in the 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So let's see, we'll put them in as well. So we have sodium, we have magnesium, we have aluminium, we have silicon, we have phosphorus, we have sulfur, we have chlorine, we have argon, then we have potassium, and we have calcium. All right, so there's my table. Okay, so we'll just draw a nice kind of little table around it. And I can probably just put each one into its own box. Okay, so I have hydrogen element number 1, sodium element number 11 next to each other, so that's fine. It works for me because they go 1 to 10 and then 11 to 20, and I'll have the next ones when they're discovered going from 21 to 30. But then I go, hang on a second, just hang on a second, this is kind of weird because I have this element here, lithium. I'm going to color it in red, all right? So this one here, lithium, and we'll colour in its atomic number as well. Lithium, when I drop it into water, it kind of explodes. It explodes in the water. It reacts violently with water. And there's only one other element in this group of 20 that I know does that as well. In fact, no, there are 2. This one here does it as well. And this one here does it. all of those elements react with water when I react very violently with water when I drop a bit of the metal into the water. And they're also all metals, which is kind of interesting. So those three are all metals, and they react with water. Now let's see. There's another situation here. I know that two of these are kind of gases, fluorine, chlorine, and helium and hydrogen. They're all gases. Oxygen's a gas. Is that getting me anything? Not really, because they all seem to be slightly different in terms of gases and properties and things. Let's have a look at the metal that's next to sodium, magnesium. Well, I know if I drop it into water, nothing much happens. But if I drop it into a weak acid, it will react quite well. I'll see bubbles of gas coming off. So if I look for other things that do the same thing as that, I end up with this picture. So there's my magnesium. I know that if I drop it into acid, it will give bubbles. What else does that? Well, beryllium does that. And calcium also does that. Okay. Well, let's think about elements perhaps that don't do very much. I know that it took me a long time to discover neon and argon and helium because they don't react with anything. They're all completely unreactive. So let's colour them in as well. All right, colour them in green. Okay, so can I rearrange my table to get the properties on top of each other? So if I take, essentially what I want to do is I've got my hydrogen here. Well, I can't really do much with hydrogen. I've got helium. Well, let's put helium in here. And then I've got lithium. Now I want to put sodium as the next one that does this thing. I want to put that underneath lithium. So let's do this. I'll stick it under there. While we're at it, helium and neon and argon do something similar. So let's put neon here and argon here. Right, so I've got those three. That's the green ones all lined up. I can get the red ones all lined up if I put calcium under there. That looks quite good. All right, then the green ones. The green ones, we've done them. The purple ones, so they would go next. So we've got beryllium. We have magnesium. And we have calcium. So now we've got a kind of a thing going on here where I have got my red ones all lined up here. I have my green ones all lined up here. And I have my purple ones all lined up here. Now, can I get the rest of them onto a table? So if we go to beryllium, I've got boron, I've got carbon, I have nitrogen, I have oxygen, and I have fluorine. And then I go to neon. And neon, that's fine. So we've got neon, we've got sodium, we've got magnesium. What we need to do now is we need to go to aluminium, silicon, phosphorus, sulfur, and chlorine. Well, that looks pretty good. So what happens is, running along here, if we ignore hydrogen for a moment, 1, 2, 3, 4, 5, 6, 7, 8. Every 8 elements I go, I can come around again to elements with a similar property. And this business of coming back to similar properties every 8 elements or so is called periodicity. And it's periodicity that allows me to design the periodic table. Now, if we look at this periodic table and instead we move neon over to here, because it's a non-metal, it's a gas, and it's a bit like fluorine and chlorine, they're both gases. So let's take argon over to here, and we'll do that. So we'll scrub out those. That means we have to put helium up here, because we want to keep it above those two. It's smaller than they are, and it has the same properties. It doesn't do anything. Where does that leave me? I have to put hydrogen in here somewhere. Well, hydrogen's a bit of a funny one because it is a gas, so it could be over here with these gases. Yeah, but it's kind of reactive as well, so it could be over here with this reactive stuff too. So we're going to leave maybe hydrogen until later. But if we look at this, we now see the makings of the periodic table. And the periodicity, the properties of the elements, let's put those in green. The properties of the elements are what puts them into these individual columns. And that's why we have 8 elements going across and not 10. I hope that helped. People understand the business of the periodic table. It's a little bit untidy, but I think you should be able to get the point. Hydrogen in the end, in most tables, ends up here. But some people put it here because it is a funny element. It can do more than one thing in chemical terms. But when we look at these elements, particularly this one, if I get my yellow pencil out, we also see that fluorine and chlorine have very similar properties. The ones in the middle maybe are less reactive. So what we've got reactive stuff over here. We've got completely unreactive stuff there, but we've got quite reactive stuff there. So this is starting to become a useful table. And what we can do is we can take our big pen out and we can draw a line through this table, because arranging them in a decimal system doesn't work. Next lesson we'll go on to look at the various groups in the periodic table and how we can use the periodic table to help us learn, to help us usefully in chemistry.